the given circuit, the charge on 4 newest capacitor will be, we have to find the charge on 4 new this capacitor. This is 1 UF, this is 5 UF, 10 volt battery is connected, and this is 3 UF. In this, the capacitor are connected using the diagram. Here, one capacitor is connected. Another capacitor is connected here. Battery is connected. And here, capacitor is connected. Now, the capacitor values are, this is 4 UF, this is 1 UF, 10 volt battery, 3 UF, and this is 5 UF. These are the charges connected. Then again we are taking the capacitors to find the charge in 4 UF. Only 2 capacitors are connected to the battery. Now we have to find the charge 4 UF. Inside that, this 1 UF plus 5 UF, totally 6 UF charges passed through this capacitor. 10 volt battery. Now battery is 10 value, Q by 4 plus Q by 6. That 2 capacitor values, 4 plus 6. 10 equal to, similarly, Q by 2, we get 1 by 2 plus 1 by 3. Q by 2, 5 by 6. So, final answer is Q equal to 24 nu C. This is the charge in capacitor 4 nu F.
Hello everyone. So the question is, two identical parallel plates, capacitor of capacitance C each, have plates of area A, separated by a distance d. The space between the plate of two capacitors is filled with 3 dielectric of equal thickness and dielectric constant K1, K2 and K3. The first capacitor is filled as shown in figure 1. This is figure 1. And the second one is filled. This is as shown in figure. This is figure number 2. If these two modified capacitors are charged by same potential V, the ratio of the energy stored in two would be E1 referred to capacitor 1, E2 to capacitor 2. So in this question they have given us two identical parallel plate capacitor and of capacitance C having area A, and they are separated by a distance D. And the space filled between the plates of two capacitors by 3 dielectrics, which are K1, K2 and K3. So they said that they are having same potential V, and we have to find the ratio of energy stored, means E1 by E2, and E1 is preferred as the energy related to capacitor first, and E2 is related to capacitor 2. So this is the first figure. So if we simplify these 2 figures, then this can be like this, means K1, K2, K3 in the first are connected in series, and in the second they are connected in parallel. So first we will find out the value of capacitor C1 and C2. As it is clear that C1 is series, so now we'll proceed with the solution. If we consider this figure 1, which means that K1, K2 are in series, so 1 upon C1 will be equal to 1 upon K1 epsilon naught A D by 3. As they given in the question that these are filled with, these are having a distance d, it means distance is d. So if we consider this distance, then this will be equal to 1 by 3, equal to 1 by 3, equal to 1 by 3, as the distance d is divided into 3 parts. So for K1 it will be d by 3, K2 it will be d by 3, and for K3 it will be d by 3. So this is K1. Considering K1, distance will be, separation distance will be d by 3. Now for K2, epsilon naught A d by 3. For K3, 1 plus K3 epsilon naught A by d by 3. So if we take common d, 3 epsilon naught A, so this will be equal to 1 upon C1 d 3 epsilon naught A 1 plus K1 1 plus K2 1 plus K3. So C1 is equal to 3 epsilon naught A by D, and this will be equal to K1, K2, K3, K1, K1 plus K2, K1 into K2. K1, K2 plus K2, K3 plus K3, K1. So this is the value of capacitor C1. Now we will calculate the value of C2, as second figure is related to C2 and we know that these are connected in parallel. So the value of capacitor C2 will be equal to K1 F epsilon naught A by D by 3 plus K2 epsilon naught A by D by 3 plus if we consider the second case, as shown in this figure, distance, separation distance is same, but area is divided into 3 parts. So area of K1 will be A by 3, as whole area is A, and for K2 it will be epsilon naught A by 3D, and for K3 it will be K3 epsilon naught A3, as area is divided into 3 parts. So this will be equal to epsilon naught A, and 3D can be taken out as common. Then this will be equal to K1 plus K2 plus K3. So we have calculated the value of C1 and C2, and now we have to calculate the value of E1 and E2. So E1 by E2 is equal to half C1 V square by half C2 V square, as E is equal to half C V square, and it is given in the question that the potential is same for both. So half and half will get cancelled out and V square will get cancelled out. So it will be C1 by C2. Now we'll put the value of C1 and C2. Value of C1 is 3 epsilon naught E d K1 K2 K3 by K1 K2 plus K2 K3 plus K3 K1 divided by C2 epsilon naught A by 3 d K1 plus K2 plus K3. Now the value of E1 by E2 will be equal to 9 K1 K2 K3 by K1 plus K2 plus K3 into K1 K2 plus K2 K3 plus K3 K1. So this is the ratio of E1 by E2, and this is our answer. Thank you.
Hello everyone, let's start the question. Question says that the parallel combination of two air-filled parallel plate capacitors of capacitance C and NC is connected to a battery of voltage V. When the capacitors are fully charged, the battery is removed, and after that, dielectric material of dielectric constant K is placed between the two plates of the first capacitors. The new potential difference of the combined system is, so in this question we have to find out the new potential difference when the battery is disconnected and the dielectric material of constant K is placed between the two plate of first capacitor. Okay, so if we draw the diagram when the battery is connected, it will be like this. So this is the capacitors, this is C and this is NC. Okay, and the battery is connected in this way. Okay, so when the battery is disconnected, this circuit will be fully charged, and this can be written as Q equal to C times V for this plus NC times V. Okay, so this will be total charge, and if we take common CB, we can write N plus 1 into CV. So this is the total charge in this circuit when the battery is removed. Okay, now for the second case, when the battery is removed, okay, so this will be the circuit, and when the dielectric material is inserted in this capacitor, okay, having constant K, the new capacitance will be K times C. Okay, initially it was C, now it is K times C, and this one will be NC. Okay, so to find out voltage, the new potential difference, we can write, we have to first find out the capacitance equivalent. Okay, C equivalence. So as this is connected in parallel, we can write C1 plus C2. So here C1 is K C plus C2 is N C. Okay, so if we take common C here, we can write K plus N into C. So how can we find the voltage? So we can find the voltage using the equation V equal to Q by C. So here the new potential difference is V dash and C is C equivalence. Okay, so if the charge is Q, we can write here N plus 1 into CV divided by C equivalent, that is K plus N into C. So here C and C both will be cancelled out. So new potential will be N plus 1 divided by K plus N into V. So if we check the options, the correct answer is the fourth one, that is N plus 1 into V divided by K plus N. So we can write the correct answer. The correct answer is N plus 1 divided by K plus N into V. Okay, V. So this is the correct answer. Thank you.
क्वेश्चन क्या है अपना, एक कैपेसिटर विद कैपेसिटेंस 5 माइक्रोफैरड इज चार्ज टू 5 माइक्रोकूलम. इफ प्लेट्स आर पुल्ड अपार्ट टू रिड्यूस द कैपेसिटेंस टू 2 माइक्रोफैरड, हाउ मच वर्क इज डन. वर्क डन अपन से पूछा है. तो देखो चार्ज कितना है कैपेसिटर पर, चार्ज इज इक्वल्स टू 5 माइक्रोकूलम. उसको आप लिख सकते हो 5 इंटू 10⁻⁻⁻6 कूलम. ठीक है, ये अपना चार्ज है. और जो इसका C1 मार्क कर दूं मैं, जिसको जो उसका कैपेसिटेंस है वो 5 माइक्रोफेरेड है. 5 इंटू 10⁻⁻6. और जो C2 है वो 2 इंटू चेंज करा है. ठीक है, अपन से वर्क डन पूछा है, तो वर्क डन जो होगा दैट इज मोड इन चेंज पोटेंशियल एनर्जी. ठीक है, और पोटेंशियल एनर्जी का चेंज अपन कैसे लिख सकते हैं, Q स्क्वायर बाई 2C1 माइनस Q स्क्वायर बाई 2C2. इसका मोड मतलब जो नेगेटिव क्वांटिटी है उसको पॉजिटिव कर देगा. ठीक है, सो बेसिकली इसमें मैं Q स्क्वायर तो कॉमन ले सकती हूँ अपना, और Q स्क्वायर का मेरा वैल्यू कितना है 25. 5 इंटू 10⁻⁻6 का स्क्वायर 1/2C1. C1 का वैल्यू कितना है 10⁻⁻6 माइनस 1/2C2 10⁻⁻6 और एक 2. ठीक है, ये लो. तो ये किस में आ जाएगा अपना, जूल में वर्क डन है. तो सो वर्क डन. अब अपना ये कैलकुलेशन सिंप्लीफाई करना है अपन को. सो 25 स्क्वायर है तो 10⁻12. ठीक है, यहाँ पे 5 टू 10, 10⁻6 10⁻⁻5 1/4 इंटू 10⁻⁻6 ये जूल. सो 25 इंटू 10⁻⁻12 इंटू 10⁻5 1/4 इंटू 10⁻6. ठीक है, अब 25 इंटू -12 प्लस 5 दैट इज -7 माइनस 25/4 इंटू 10⁻⁻6. सो इसमें क्या करेंगे अपन, 25 इंटू 10 टू द पावर -7 अपन ने कॉमन ले लिया, सो 1 माइनस यहाँ पे 1/4 इंटू 10, सो इसीलिए अपन ने मोड लगाया था क्योंकि ये वैल्यू जो अपना नेगेटिव आने वाला है। सो 25 इंटू 10 टू द पावर -7, 10/4, तो यहाँ पे -6/4 आ जाएगा अपना, और ये मोड, तो मोड का यही काम था कि इस -6/4 को +6/4 में लिख सकूं, इंटू 25 इंटू 10 टू द पावर -7 जूल। सो इसका जो वैल्यू है अपना वो आ जाएगा 3.75 इंटू 10 टू द पावर -6 जूल। तो अपना कौन सा ऑप्शन करेक्ट आ जाएगा, ऑप्शन सेकंड इज करेक्ट। ओके, थैंक यू स्टूडेंट्स।
Hello everyone, the question says that a parallel plate capacitor with plate area 1 meter square each are at separation of 0.1 meter. If the electric field between the plates is 100 Newton per Coulomb, the magnitude of charge on each plate is, taking epsilon equals to 8.85 into 10 raised to power minus 12. As we know formula to find out electric field, that is E equals to sigma upon epsilon naught, where sigma is the density and electron density. Sigma, we can write sigma as charge per unit area, that is it's a surface charge density, that will be equals to Q upon A, epsilon naught will be as it is. Now on multiplication, so we get Q equals to A E epsilon. Now we have given area A is 1 meter square, value of electric field is 100 Newton per Coulomb, and epsilon naught is 8.85 into 10 raised to power minus 12. Now on solving this value, we get value as 8.85 into 10 raised to power minus 12, and this will equals to minus 10 Coulomb. Hence, so right option is C. Hence option C is right. I hope you understood this explanation. Thank you.